friends, welcome back to my channel. So today I'm going to explain you numericals based on star delta conversions. So a problem is shown on the figure. So find the effective resistance between A and B. Now whenever the problem is given like that, first of all you have to look for the resistances whether they are in series or parallel. Suppose if they are in series or parallel, use those rules to get the effective resistance between A and B. But in our case now, if you can see, the given resistance network is not either in series nor in a parallel. So we have to use other methods here. So the other methods we already discussed how to convert a delta to star and star to delta here. Now in this one, actually if you look at situation here, two deltas are there. So now the question arises whether we have to convert the two deltas to a star. No. The rule is here whenever two deltas are there, you are advised to convert only one delta to the star so that the problem will be simplified here. Now in our problem you can see there are two deltas here, but you have to convert any one of them. Suppose let us consider this one I am going to convert into star here so that the problem can be solved. So let us write the delta in separate figure. So this is converted into like this. So this is RA, this is RB, this is RC, this one R1, this is R2, this is R3. And we know the R1, R2, R3 formulas that we discussed in the earlier videos here. So what is R1 equal to here? R1 equal to the formula is RA RB divided by RA plus RB plus RC. And similarly R2 equal to what we can write here, this is RB RC divided by RA plus RB plus RC. And R3 equal to this is RA RC by RA plus RB plus RC. Now in our problem, what is RA here? RA is 30 and RB also 30, RC also 30 here. So what happens here? R1 becomes what here? 30 into 30 divided by 30 plus 30 plus 30. So we get what here? This is 900 divided by 90. We get 10 ohms. Similarly, we get for R2 also 10 ohms and R3 also we get 10 ohms here. Now what happens here? Now the figure will be reduced here. So what is the new figure here? The new figure will be like this here. The new figure will look like this here. Now you can see this will be like this. And this 10 ohms comes like this, and this is B. Now this is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm. Now you can see these two are in series and these two are also series. So 10 and 10 becomes 20, 10 and 10 becomes 20. Now the figure will reduce to like this here. This is 10 ohm, this is 20 ohm, this is 20 ohm, and 20 20 are parallel, so their resultant becomes 10 ohms here. So now the figure will reduce to what here? The figure will comes out to be, this is 10 ohm is there, and this 20 20 again becomes what here? 10 here. So A and B, this is 10 ohm, this is 10 ohm, and therefore effective resistance between A and B. Because 10 and 10 are series, we get what here? 10 plus 10 equal to 20 ohm. Okay, so this is one of the utilization of this delta to star conversion problem. You can see the given figure is like this. Now finally it is reduced to the smallest one like this here, so that the problem solving becomes very easy here. Okay friends, this is another problem you can see, and we are asked to find the effective resistance between A and B. Now you can see here three deltas are there. All resistors are carrying only 1 ohm here. They are neither in series nor parallel. And here we can use this delta to star conversion again, so that the problem becomes very simple. Now you can see here there are three deltas are there. So but if the question arises whether we have to convert all of them into star, no. So you have to convert the middle one, so that the problem will be simpler. That means this one is going to be converted. This one is going to be converted like this. This one will be converted like this, so that the problem becomes very simple. That means what is the situation here? We are having the situation like this. Okay, and we are going to convert like this. Okay, now you know this is whatever it may be, the same thing you are going to get here. So if you consider this is RA, this is RB, this is RC, then in between whatever comes, that we call as R1, this is called as R2, this is called as R3 here. So R1 equal to, what is the formula here? R1 equal to, we know that RA RB by RA plus RB plus RC. So similar to earlier one, that is we already completed here. So RA RB like this here. Same thing. So because all values are equal, you can substitute the same. 1 into 1 by 1 plus 1 plus 1. So we get 1 by 3. That means we get R2 also equal to 1 by 3. R3 also equal to 1 by 3 we get. Now what happens here? The formula, once we got the values, this figure will now reduce to, so I'm drawing this one. That means these three resistors are now replaced by this one. That is, this ohm and this 1 ohm will exist here. And now we are having like this. Now you can see here the problem now becomes simpler here. This is 1 ohm, this is 1 ohm, this is 1 ohm. These are already existing one, but this is 1 by 3, this is 1 by 3, this is 1 by 3. Now 1 and 1 by 3, these two are in series and these two are in series. So just add them. So what you get here? You will get the figure like this here. So 1 plus 1 by 3 means what you get here? 1 plus 1 by 3, you are going to get to 4 by 3. So this will be 4 by 3 and 4 by 3. Okay, this is 1 ohm. So 1 by 3 ohm. Okay, let me correct it. This is 1 ohm, this is 1 ohm. Okay, now if you look at this figure here, it is like a Wheatstone bridge. This figure will be equal to what here? Wheatstone bridge. So Wheatstone bridge balancing condition is satisfied. What is the balancing condition? You know, this is P, Q, R, S. So if P by Q equal to R by S, then that central resistor becomes ineffective and that can be eliminated. This is 4 by 3, 4 by 3 equal to 1 by 1. So now the figure will reduce to like this. So this is 4 by 3, this is 4 by 3, this is 1, this is 1. These two are series, becomes 8 by 3, these two are series, becomes 2, 1 plus 1, 2. And then now the figure becomes like this here. AB, this is 8 by 3, this is 2. And 8 by 3 and 2 are now parallel. So therefore R effective equal to 8 by 3 into 2 divided by 8 by 3 plus 2. So here numerator we get 16 by 3, denominator we get 3 to the 6 plus 8 14 by 3. So 3 gets cancelled. So R effective becomes how much here? 8 by 7. So this is the result of this given network here. So which is a 3 deltas are there, but we converted only one, and we got Wheatstone bridge balancing condition in between them, and finally we arrived at the expression that is 8 by 7 ohm here.